Welcome back. With a strong foundation in DBT concepts and modeling, the next step is to explore advanced DBT features that are commonly used in real-world projects. This section focuses on snapshots, macros, variables, and reusable components, which help manage historical data and build scalable, maintainable analytics systems. In this subtopic, we will understand how DBT tracks data changes over time using snapshots, how advanced macros and variables reduce repetitive logic, and how packages and dispatch mechanisms support complex production environments. These concepts are especially important when working with slowly changing data and enterprise-level pipelines. What is a snapshot in DBT? Answer: a snapshot in DBT is used to capture and store historical changes in a table. It records how data values change over time instead of keeping only the latest state. DBT snapshots maintain multiple versions of the same record. This is especially useful for audit and historical analysis. Why are DBT snapshots needed? Answer: many source systems overwrite old data instead of preserving history. DBT snapshots help retain previous values of records. They enable time-based analysis and trend comparison. Snapshots ensure historical accuracy in reporting. How are DBT snapshots different from models? Answer: DBT models represent the current state of transformed data. Snapshots store historical versions of records. Models are rebuilt or updated regularly. Snapshots track how data changes across time. Where are DBT snapshots defined? Answer: DBT snapshots are defined in snapshot files. These files contain SQL queries similar to models. Snapshot-specific configurations control behavior. They are kept separate from transformation models. What is the snapshot strategy in DBT? Answer: snapshot strategy determines how DBT detects data changes. It defines the logic used to compare old and new records. Common strategies include timestamp and check. Correct strategy selection ensures accurate change tracking. What is the timestamp strategy in DBT snapshots? Answer: the timestamp strategy uses a last updated column. DBT detects changes based on timestamp values. New records are captured when the timestamp changes. This strategy is simple and efficient when timestamps exist. What is the check strategy in DBT snapshots? Answer: the check strategy compares selected column values. It does not rely on update timestamps. DBT inserts new records when values change. This is useful for legacy systems without timestamps. What columns does DBT add automatically to snapshots? Answer: DBT adds valid underscore from and valid underscore to columns. These columns define the time range of each record version. They indicate when a record was active. This supports historical and time-based queries. What is slowly changing dimension, SCD, in DBT? Answer: slowly changing dimensions track changes in dimension data. DBT snapshots implement SCD Type 2. Each change creates a new record version. Historical values are preserved for reporting. What happens when a snapshot record changes? Answer: DBT closes the existing record by updating valid underscore to. A new record is inserted with updated values. Both old and new records coexist. This preserves full change history. How are DBT snapshots executed? Answer: snapshots are executed using the DBT snapshot command. They are usually scheduled to run regularly. Snapshots run independently from models. Automation ensures consistent history tracking. Why are unique keys important in DBT snapshots? Answer: unique keys identify records correctly. DBT uses them to match old and new data. Incorrect keys cause duplicate history. Proper keys are essential for accuracy. How does DBT handle deleted records in snapshots? Answer: DBT marks deleted records as inactive. The valid underscore to column is updated. Records are not physically removed. Historical data remains available. What are advanced DBT macros used for? Answer: advanced macros automate complex SQL logic. They support dynamic and reusable transformations. Macros reduce repeated code. This improves maintainability and consistency. What are DBT variables? Answer: DBT variables store configurable values. They are defined in project or environment settings. Variables allow dynamic behavior in models. They support environment-based logic. How does DBT support environment-specific behavior? Answer: DBT uses targets and variables. Logic can change based on environment. This protects production systems. It improves deployment flexibility. What is the DBT dispatch mechanism? Answer: dispatch allows overriding macros dynamically. It supports warehouse-specific implementations. Used in multi-database projects. Improves portability and customization. What is a DBT package? Answer: a DBT package is reusable code shared across projects. It may contain models, macros, and tests. Packages follow best practices. They speed up development. Why are DBT packages useful? Answer: they provide pre-built functionality, reduce development time, promote standardized logic, improve project consistency. What is the role of packages.yml in DBT? Answer: packages.yml defines external dependencies. It controls package versions, ensures reproducibility, supports dependency management. What is semantic consistency in DBT? Answer: semantic consistency ensures metrics mean the same everywhere. It avoids conflicting calculations, builds trust in analytics, achieved through standardized models. How does DBT support reusable business logic? Answer: DBT uses macros and intermediate models. Logic is centralized, reduces errors and duplication, improves long-term maintenance. What is advanced ref usage in DBT? Answer: ref manages dependencies safely. It allows refactoring without breaking pipelines, supports modular architecture, improves project stability. Why are advanced DBT features important for interviews? Answer: interviewers test real-world experience. Advanced features show depth of knowledge. Snapshots are commonly asked. Strong answers differentiate candidates. How do advanced DBT features improve production stability? Answer: snapshots preserve historical accuracy. Macros reduce human errors. Variables control environments. Overall system reliability improves. Thank you for watching ZoomInData. Subscribe and follow for more content.